Welcome back, code artists. Uh, we've got a lot of material to cover in these next few videos. The overarching topic is called programming sequence. There's really three parts to any computer program. It's sequence, selection, and looping. So with this first part right here, we've got so much material to cover. As you can see, there's a huge wall of code here, and then down below are all these topics I need to get through for the first section that we will probably break this up into a couple of videos. So I'll call it like code 3.1 on the YouTube channel and code 3.2. I don't think I need to do more than 2 videos, so let's jump right into it. So we're going to be covering functions, sequence, variables, parameters, constants, what scope means, mutation terms, which is mutable, immutable, and mutate, the different data types, number, string, boolean, null, undefined, concatenation, and the 3 types of JavaScript quoting, and 2 of them are the same thing, so it's even easier than you think. The different mathematical operators, plus, minus, forward slash for division, asterisk for multiplication, modulus for division remainder, and then the new exponent operator. Escape characters, which we put inside of our strings, for example, right here, that do different things to the string output. Console logging, as you can see right here on line 68. And then I'm going to introduce you to just my 10 commandments of programming that I teach my students to just kind of get them into the good habits of good coding practices. So down here are all the different URLs this code is, of course, on our repository. Feel free to go through and check all these out. They are really important source material for a lot of what we're covering in these videos. So in this video, let's start with talking about functions and sequence, which is a little different than a lot of other videos do. They want to start you out with variables and constants and data types and operators. But I think it's supremely important to learn how to modularize your code first before we jump into how we're going to store data into memory, and because everything we do is based on this modularization technique. So before we do that, I want to kind of give you some foreshadowing of the code. As you can see, here's all my JS doc comments. They're all over the place, and it just makes our code look twice as big as it really is. So the nice thing about IntelliJ is, as you can see here, we've got these minuses, and we can roll up certain sections of our code. So I'm going to go through and roll some of this up because you've seen it before. But before I do that, I want to go through and just show you the different keywords that I'm using with JSDoc. So I've got this right here, which is saying that this is a method. Here's the description of the method, and it returns nothing, right? If we come down here to this method down here, this is my age mutator. This has a new keyword called @param, which stands for a parameter, and this means I'm passing in a parameter of data type int, and it's called current year. As you can see, the parameter I'm passing in is current year, and then over here is with a space hyphen space is a description of what the parameter is for. So I just wanted to go over that with you before I roll these up, just to kind of explain what's going on. So I'm going to click on all of these minuses right here, and you'll see our code just shrinks down quite a bit so that it's a lot less that we have to worry about. So essentially our code really, we're looking at line 8 through 70 there, with a bunch of things rolled up. As you can see, there's missing line numbers in there, and that's because it's inside of those pluses. Okay, so the way that we modularize the code, at least for my class and for my students, is that I have this kind of guideline for these beginning lessons that whenever you declare a global variable, up here in our section 2 of our code, whenever you declare those, you should have an associated mutator method down in section 4 that assigns value to that variable using this assignment operator, which we'll talk about later when we get into variables. And the reason for that is it allows us to not do anything up here permanently up in section 2 other than open the memory space, which is what variables really are. We're opening up space inside of the random access memory of the computer to be able to store values. This gives us way more flexibility because we can call this now anytime we want to and reassign value to that. So having the code modularized and cohesive, which is a term that follows one of our 10 commandments of programming guidelines, all of our methods should be cohesive, meaning they only do one thing. For example, this particular method right here is only assigning value to the last name variable. It's not doing last name and first name at the same time. So that makes our method cohesive. We also want our methods to be loosely coupled, meaning you don't need to run this method and this method in order to get this method to run properly. Where at all possible, try to make your methods be basically independent, tiny little programs inside of your main program. And that's really what methods are. They're small programs or mini programs inside of your bigger macro program. And the sequence part of coding means the code is run top down sequentially except for as it sees these methods. And so what I mean by that is when the compiler comes along and it sees a method definition, it goes ahead and loads all this into its brain, but it doesn't run the code yet until it receives the call to run the code, meaning, okay, go ahead and run the main method. And that actually happens down here on line 28. So essentially this code right here is read top down. It sees this line 28 right here, stops what it's doing, goes up to the opening curly brace of this block right here, and curly braces are blocks of code. It goes to this opening curly brace and it runs everything it sees top down, line by line. And as you can see, when it runs it top down, line by line, we hit other method calls right here. So what that means is it's going to hit line 22, stop processing inside of here, and find this method right here, which is down here on line 35, and it runs its code top down sequentially, starting from this curly brace until it gets to this curly brace. So what it does is it runs this line of code right here, and then it hits this closed curly brace, and then it goes back up to this end semicolon, and then it continues on down sequentially. And each one of these is a separate method call. So, and that's exactly what's going to happen. So that's what it means by sequentially. It doesn't necessarily mean that it does this file top down. It does each method that it finds top down. So another word about semicolons that we talked about in a previous video. Again, these are to terminate statements in this particular language and in most programming languages for that matter. So it's kind of like the end of an English sentence. When you're writing a paper, this says this is the end of this statement and go ahead and move on to the next one. You'll notice that since a block, which are two curly braces, an open curly brace and an end curly brace, is not really a statement. This is self-terminating, meaning when it reaches this curly brace right here, it's going to go ahead and stop processing that block and then move on to the next section of code. So that's it for functions and sequence. I can't think of anything else other than I want to talk about the next thing for our 10 commandments of programming is self-documenting code. Notice that this name of this function right here, or method, is called setLastName. And this is telling me, the person, that this method is designed to mutate or give value to this variable up here, last name. This and this are not related to each other at all to the compiler. This is just for humans. Where they are related is what I do inside. I am mutating last name, so I have to use the assignment operator here, and that is related to this global last name. This, I could have called this anything I wanted to. I could have called it Fishy Chicken Widgets, and I could have called it up here Fishy Chicken Widgets, and these two are related, but I make that self-documenting by saying set last name for the human to know that I'm working with this variable right here. And that is, for some reason, that is a huge hurdle for a lot of beginning programmers to overcome. So please really make sure you understand that the name of this method to the compiler, not to the humans, but to the compiler, is in no way related to the variable name. I could have called it anything I wanted to. It's the stuff that goes on the inside of the method is where you make it relate to something, you know, more global, like this particular variable right here. And the next thing I want to talk about with functions is the way that I teach my students to do dispatching. So instead of having just a bunch of functions with function calls right below them out in the open of the code like this, I like to allow them to write the functions all out and then call them in the order that they want them run by using this dispatch method right here called main. And that's the pretty common convention that I've used for years. So they have a main method, and they put in the calls to all of the functions in the order that they want them to run, top down in here, and then the code runs it. It doesn't matter what order they are down here in section 4. It runs them in the order that they put them inside of this main method, and then the call to the dispatch method or the main method goes right below the main method. So it makes it more, what am I looking for here? It makes it easier because we can go in here, for example, and say we're trying to debug our code. I can simply turn off that method call right there and only work with the methods that I think I'm having trouble with. Or I can do, I want to turn all of this section off right here, so I can just turn off the whole section by doing an IntelliJ Control-Shift//, which puts a comment block or a block comment around those section of method calls. And so now I'm only doing these two lines right here. And when I want to turn that back off again, if I just do Control-Shift/, it turns it back off again. So the whole dispatching idea, I think it's incredibly beneficial for people, and it makes coding a lot easier. Okay. Let's see. What do we want to cover next on our list right here of our Programming 10 Commandments? Consistent proper style. What that means is if you, at least for this beginning portion of this class, and frankly I do it with all of my code anyway, at least for this beginning portion of this class, if you do all of your code with 4 sections like I've taught you, where you have section 1 up here, which is your comment header block, your usage pragma, and then any of your library calls, your global library calls. Then do your section 2, which is your global variable and constant section. And then section 3 is your dispatch section. And then section 4 are all of your mutator and worker methods. I think that consistent proper style will make it much easier for you to learn programming, because you'll be basically having a code template for each new code that you start, each new program that you go to start to do. So I think that's it for right now for the 10 Commandments of programming, but we'll get into some more as we get into the variables and different data types. Where are we with time on this video? We're at 14 minutes, so I'm going to call it, and then we'll, on 3.2, we'll talk about hopefully everything else if I can squeeze it in there. If not, I might have to break this up into 3 videos. So thank you for watching.